In this first example, we're going to use z equals x minus mu over lambda to change a normal distribution into a standard distribution. And we're going to use the formula booklet tables from the SL course. We're not going to use a calculator for this first section. So what have we got? We have, given that we've got a normal distribution with a mean of 50 and a variance of 9, be careful with this, it's a variance that's 9, so the standard deviation is 3. Be careful of that, that's tricky. You'll maybe fall over flat on the face if you're not careful with that. My diagram, my sketch, has a 50. It's got a standard deviation of 3. So 53 might be down here somewhere. That's one standard deviation away. And from what we've looked before, if it's one standard deviation to the right here, well, halfway is 50%. So we have 50% here. And we saw that this was 34.1%. So even to that point, we've got 84% of the population. So we know our answer to this has got to be more than 84%, because the number 55 is further to the right, and so we're going to end up with that. Alright, now something's gone a bit strange there. Yep. Stay with me while I do that again. The wonders of technology. There we go. Beautiful. Right. So we know it's bigger than one standard deviation away from the mean. Let's have a look. We're going to use the z equals x, well, x value in this case is 55, minus the mean, x minus mu, x minus the mean, over the standard deviation. This gives us a value for our z as 5 over 3, which is 1.67. Now, if you look at the tables, and I've got a copy down here, you'll see that you can only do 2 decimal places. Let's find 1.67, which is 1.6 across the left column there, and then 7 across the top. So 1.67 is that value there. Okay. So what we're saying is the probability that x is less than 55 has exactly the same area as the probability that z is less than minus 1.67. What we mean by that is we're transforming our original distribution and we're making it into a standard distribution which has got a mean of 0 and a standard deviation of 1. So our value is 1.67 in this particular distribution. So down here is what we're looking at. And bear in mind that the tables that we've got only work for this particular distribution. So we're using the values from the standard normal. We're saying that the area of the curve on the bottom there is identical to the area of the curve on the top. Therefore, the probabilities are the same. All we have to do then is look at where does z equal 1.67. Well, we saw that before. 1.67 was 0.9525. So 0.9525, which is approximately 0.953, or 95.3% of that distribution is less than 55. Okay, that's done, finished.